Yeah.
Hi, peoples.
Hey, I heard a rumor that Brian was going to be on good behavior.
No.
Hey guys, welcome.
It's that rumor.
We'll wait for more people to enter and we'll get
Of
started.
course.
Say hi to Mike and Brian. They can see your comments on our iPad, so
Hi, Mike and
leave
Brian.
them comments. 18 people so far.
18.
Woo.
Well, it's only we got
Meeting March 18th at 4 p.m. We're going to be doing the next Buckle Up with Mike and Brian on charging and tuning. Brian's been picking on me all day. No.
People are saying hi.
welcome to
Hi guys.
welcome to our
Hey, Cooper
temporary
Kid.
Buckle Up with Mike and Brian studio.
Okay.
I told you last time, wait till you see our new one. It's going to be fantastic. But we got a lot of things going on, so just like you guys, adapt, overcome, and welcome to the hottest frigging studio I've ever been in my life. It's probably 90 degrees in here. For you guys in Texas or the cold areas of this country, sorry to mention that it's 90 degrees in here. Holy cow.
I'm just loving the 15-second delay.
So we before we get into this, you guys know what this part. What is this part? What the hell are we doing, Mike?
Electrical troubleshooting.
Electrical troubleshooting today?
Do we need to start with the disclaimer?
Yeah.
If you stick your fingers in there,
And
it
get-
can hurt like hell.
Yeah. True.
Yeah.
True that. So lick your fingers
Yeah.
twice before.
And make sure you're leaning against a metal wall and stuff like that. It
Nate
works
says
so much
hi.
better.
Nate says hi. Hi, Nate.
Hi, Nate.
Hi, Nate.
All
Shout out.
right.
I gotta do my shout outs. I got a shout out to Josh. Josh was supposed to have all of his guys. They had a team meeting today, and he was gonna have all of his guys download the free app. And we set him up with some information last night. So Josh, hope your meeting went well. Peace, brother. Welcome to the Buckle Up.
Okay, we're ready to get started. We have 35 people on right now. So welcome to our fourth Buckle Up with Mike and Brian. Crazy how it's already the fourth one.
Hey.
As they said, this segment is on electrical troubleshooting.
Fun
So
times.
if you have any questions, be sure to leave them in the chat. And as you guys know, we're trying to stump them. And whoever does stump them will get a package of really cool gear from Blue On. So ask the hardest questions ever. Because
I'm
they
not
have,
sending the gear.
between the two of them, they have over 70 years of experience in the trade. So if you stump them, that's a pretty big deal.
It makes us sound pretty damn old.
It does. So we got to ask them the question: does electricity go plus to minus or minus to plus?
It's not a battery.
Okay, let them
Anyone in the chat?
Hmm?
Okay, let's start.
I told you this subject is, they're going to get such a difference of opinion between.
We're going to start with the questions we got sent in today. So, first one, how do you get good with the wiring and schematics? Because that's really where I'm struggling right now.
I think the best way to get good with wiring schematics is to figure out what they're doing, like for your fan control, and look at your safeties, and just trace out the schematic. If you can print it out, one thing that's kind of easy to make it easier is get a highlighter and just follow the wiring as it goes. So you kind of see what they're doing. You'll start picking up on the fan circuits, compressor circuits, and some of the different circuits that are in there, and it'll all start making sense. Because like everything else, it's like your basics. You have a bunch of series circuits, and then you start adding on to them. So take a deep dive in the drawings, spend a little time, and like anything else, it gets easier with time.
Get comfortable. Can you throw me my director? Can you throw me a mechanical pencil? Mechanical pencil. Yeah, right. Any one of those. Bring it. Throw it. Perfect. Mechanical pencil incoming. So, little trick for you guys learning to read wiring diagrams because it gets overwhelming. If you take a mechanical pencil and follow the line wherever it's going, and get to all the circuits until you get used to looking at, because there's ladder diagrams and schematic diagrams. So get just anything that will train your eye to follow those wires. Because when you're looking at a machine, there are multiple colors unless it's a train. which is all black, and then you have to read the numbers, and when you get these, and then you get some more of these. At any rate, but that's how I get through a lot of those diagrams, is just with the mechanical. So thank you. Throwing that back up on the producer's desk. Perfect.
Okay.
I made it. I get
Bonus points.
So next one, this was sent in from Richard, and he asks, what is the name of a current that induces another current?
A transformer.
Cool. All right. Next.
It could also be
Well-
inductive capacitance.
It could, or a buck and boost, or
Stick 2 wires in parallel, one of them with 480 and nothing on the other one. Grab the other two and see what happens.
ooh no,
Yeah.
that's bad. Made a transformer. At any rate, yeah, that's what we're doing. Thanks, Richard. Appreciate the question.
All right. So we got one in the chat. He's asking which one is better, 120 volt mini split or 130 volt mini split. 230 volt mini split.
Which is better, a 120 volt mini split or a 230 volt mini split? And the answer to that question is it really doesn't matter. If you think by changing the voltage that you're going to be changing your amperage and what the customer is going to have to pay, that's a bad thought process. 15 amps is 15 amps, whether you're using 7.5 on each leg or 15 on one.
You get the difference occurring when you go from single phase to 3 phase.
True.
Yep.
All right. So we have another one in the chat. Does following a schematic start from left to right?
No, it starts where I put my pen.
You know, one way to do it is if you're looking for a compressor contactor to pull in, find the compressor contactor and work your way back. You know, look for any safeties that may be in the circuit, anything that could cause a problem. And one of the things this is going to be really, really helpful. Check and make sure you have your line voltage and make sure you have your control voltage, because otherwise you can look until hell freezes over and it ain't going to work.
So on a more I always start off the answers with being a smartass. But when you're looking at a schematic, I do it the same way I do to test out a machine. I check to see if my high voltage is there at the disconnect, come into the machine and check and see if it's there. And I do the same thing on the schematic. I like the ladder because you bring in your high voltage, then you see the transformer, and then it breaks into your low voltage common being on the left or on the right, high voltage, your 24 volts being on the left, and where everything meets. So is it left to right? Not necessarily. I read top to bottom. But like Mike pointed out, if you're having a problem that the voltage is not getting to the contactor coil, if you go to the contactor coil and work your way back to Y.
Yep.
All right. One from Mr. Smartwater. Why do we need a true RMS meter to do readings on a variable speed compressor?
Oh. It's true RMS.
Come on, Mike.
No, it's just I haven't played with that stuff in years.
Is this a stump?
True.
No, I
it's
mean-
not.
I
It's
mean,
not going to stump
Do
us.
we stump
It's not
him?
going to stump us. I'm going to help Mikey.
Phone a friend.
True RMS is when you AC voltage, and then you have a VFD. VFD takes a alternating current and makes a simulated alternating current. So you need to read the true RMS doesn't have the loop. It's just a squared off signal. So when you go from AC volts to simulated AC volts, if you want to read the true voltage, you need the true RMS.
It's 0.707 of the peak voltage, but who's counting?
Told you I was going to help his memory. Come on, bring it.
All right. So we have an interesting question. What's the worst shock you've ever gotten?
Standing on an aluminum ladder in a walk-in freezer, 277 volts. 277 is a bitch. It hurts like hell. Yeah. And shorted out to the ladder and grabbing the wrong wire, and I still remember to this day.
I got two. I got bit off of a capacitor. That hurt. I asked the gentleman to shut off the power. He shut off the power. I did not confirm. The machine had 2 breakers, and I reached in on the control circuit and got hit with 220 volts. And it was 7 o'clock at night. I said, I'm done for the day, and packed up my dolls, dishes, tools, and buckets, and got in the truck, came back and dealt with it the next day. So I actually survived a 230 volt straight hit.
Without going into a lot of detail, I had one like that when I was military, 17 years old. And the guy kept saying, are you sure the power's off? And I go, yeah, the breaker's off. And he goes, but are you sure the power's off? Yeah, I'm good. And he kept asking me, and I'm just like, shut up, I'm good. Stuck my hands in there, got knocked on my ass. He's laughing his ass off, and I did what a 17-year-old has to do. And I paid the price for it. He told me, he says, I guarantee you'll remember this as long as you live. That was 44 years ago.
44. I remember my dumb mistakes.
Oh,
too.
yeah.
We have one from Adrian, and he's asking, I had a compressor seized on a 208 volt 3-phase heat pump. The breaker that served the heat pump didn't trip, and the main that served the breaker panel fuse blew. Why didn't the breaker trip?
Depends on what the load was on the main breaker and how close it was to being overloaded. So when you overloaded the breaker, it was probably cold to start with. You had a warm breaker in the main, and so just the surge was enough to cause that one to trip. Remember, breakers are thermal devices, so it's heat related.
And the fuse, depending upon whether they had the slow blow or a one-time, the fuse could have picked up that faster.
All right, just as a reminder, guys, we're trying to stump the two of them. So drop your questions in the chat about electrical troubleshooting.
I want to know if I stumped the guys.
Have you ever worked in a building with interstitial floors? Yes.
Oh yeah, Cedar Sinai in an earthquake. That was fun.
Yes, I have, but thanks for asking.
Someone asked, can I use a fan relay board on an ECM motor?
Theoretically, yes. You could use it to switch the 24 volts going to the control voltage.
Well, you could use it to shut off the high voltage too,
Yeah,
but
a lot of things
why
you can do.
Why would you want to? You can add a whole bunch of shit to a machine that doesn't.
I
need
can
to
get
be
creative as all hell.
Okay, let's go to another one that was sent in earlier today through email. Raphael says, I'm an HVAC student and sometimes I get confused with other techs' use of the word common as it pertains to the electrical wiring in a unit.
Well, it's a very common question.
That is a very common question. If you think about the term common, it is a common point. I'll kind of digress just a little bit. I've seen a lot of techs lately wanting to read 24 volts to ground as a reference. That works great if the secondary of the transformer is grounded.
If the common on the
The
transformer.
common is, you can call it common, you can call it whatever you want. It's AC, so take your pick. But no, it's a common point. So, everything goes back to that one common. It's one side of your transformer. I really hate it when they call the neutral the common. It's not. The neutral is a neutral, a common is a common.
And
Common
ground is ground.
Yeah.
But
It could be potential, it could be circuit, it could be.
it could, but now take a 120 circuit. You've got hot, neutral, and ground.
Uh-huh,
And guys refer to the neutral or the white wire as common
uh-huh.
because they go back to a common bus in the panel.
But so does the ground.
I know, same opposite side of the breaker panel, but yes, they go to the common bus, which goes to ground. But at any rate, so common can be used. The point being is common is used in a lot of different terms, and most guys are referring to the negative side of the transformer instead of the positive side. So you have 24 plus, 24 minus. The 24 minus is quite often referred to as the common side of the transformer.
How do you get that
The
on
C terminal on the board or thermostat. I know where you're going, man. I've known you too damn long.
Let's do the next one from George. He's asking, why would a compressor draw double FLA with perfect pressure, temp, voltage, and 0 voltage drop?
Well, because it's working working its way from FLA to LRA. What's the LRA number? If you've exceeded the FLA number, FLA is full load amps, guys. So that's what it's supposed to be drawing at max. It's not supposed to go over full load. So the next number in that equation is lock rotor. So you want to look at the locked rotor and see what that is. Now look at your amp draw, and if you're between full load and locked rotor, if it's a single phase compressor, look at your capacitors. If it's a 3-phase compressor, I'd be looking at power issues.
Yep.
Next one from Kenneth, and he's asking, what's some advice for a teenager that wants to become an HVAC tech?
Get in the trade.
Yes.
Get yourself into a school, and learn the trade. I grew up in the life of hard knocks. Being that we run a lot of tech support calls. There's guys out there that are still running into the life of hard knocks, and that's a hell of a learning curve, but it's a curve. So yeah, I highly recommend any youngster that wants to get into this trade. It's a fantastic trade. We joked about it earlier that between Mike and I, we got 100 years. I've got 40. I started when I was 17 years old. I'm still doing it. I'm still smiling. And yeah, I mean, I can't think of anything that I've done better.
In all seriousness, and we just saw a video on this, where there's going to be something like 31 million people short in the trades: welding, plumbing, electrical, HVAC. And the thing is, before you could get a college, you could go to a union apprenticeship, and now there's a lot of trade schools that are offering it. So, get out there, get in some classes and that, and it's a good trade. You can make good money. And one of the guys was joking. He says, it really pisses me off. He says, I got these youngsters that pull up to the shop in a Porsche and jump in their service trucks. So, it's a good living, guys. And young ladies.
Important. Okay. Next one. What's your opinion on using a cheap mega ohm tester on PMs to predict motors going bad?
Oh,
Depends on the machine. I wouldn't do it on anything under 20 tons.
yeah, I mean,
myself.
the thing is, it's like they used to do the MEG testing on stuff that was working on drives. And it's like, hey, I got a bad number. It's lower than it should be. It's like, is the motor bad? No. And the damn motor run for another 20 years. So,
Right.
You're not going to replace a motor just because it's low. I use a MEG ohm more as a diagnostic tool than a predictive tool.
Yeah, like I say, anything under 20. I mean, I got my megger out when I was doing my annuals on the centrifugals. But that was also to check the spark plugs, the wire connections, to make sure that they weren't cracked. And I mean, there's a lot of preventative maintenance stuff you can do. But, I mean...
And if one of the old timers hands you the 2 leads and says, hold this while I crank this, don't do it, it will hurt.
Mikey, they don't crank them anymore, dude.
Oh, I still got my Yokogawa, dude.
I've seen your car. You crank it to start it. It's all right.
All right. Next one. What is back EMF?
That's a fun one. If you have a large, heavy fan motor, typically on a variable speed drive, and you slow it down very, very quickly, you get the motor acting as a generator, and it pumps up the DC bus. Now, if you want to get really interesting, you can put in some devices, and you can actually redistribute that out to other motors.
Don't take Mikey down the weeds of VFDs. Remember, it was not that long ago in questions, I got his brain spinning, right? He's back in.
What is a Wheatstone bridge?
A Wheatstone bridge is used for reading
It's a mouse trap.
extremely precise resistance. Back in the day, when we had Simpson 260s and stuff like that, it wasn't all that great, but the meters that are out there now are unbelievably precise.
Well, yeah, it's the old school carrier mousetrap.
Mhm.
So you take a resistance voltage here and send it through, and it matches the resistance voltage here. So this temperature changes and it moves the mousetrap. So that.
big.
Old. If you've got a machine out there with a Wheatstone bridge, I would love to have a picture of it because I haven't worked on a Carrier 38 in a long time. So take a picture of it and email it to me. I'd love to have one in my library.
Okay, negative effects of using higher wire gauge than needed.
There are no negative effects other than cost and conduit sizing.
Well, I see. I told you we're going to have a difference of opinion.
Go for it.
If you're using too large a wire on 24 volts, your VA is not going to be enough to keep things up running.
You can run longer distances without a voltage drop.
See? But then having undersized wire does the same thing.
Yeah.
If you're undersized, you have more problems than if you're oversized.
Yep.
All right, next one. As a young apprentice, how does jump starting a locked compressor work?
If it's locked, it's probably locked.
Again, it depends on whether it is three-phase or single-phase. You're not going to jump start a three-phase compressor. I've seen guys reverse two poles to see if it will unlock.
Yeah, break it loose.
But back in the day, we used to take a buck and boost or a buck transformer and give it a shot. Now they make the plug-on hard start
Yeah.
kits.
The problem is if it's already locked up, what's the point?
So if you want to try and free it and put a hard start kit on it, and knowing that you're going to come back. Maybe
Yep.
it's 6 months, maybe it's a year, or maybe it's tomorrow.
All right, I'm gonna talk about some scenarios that we've gotten through tech support recently. Favorite topic. So this guy says that he has an electrical indoor blower motor that runs constantly. When I remove 24 volts from the ECM, the motor keeps running. What do I do?
Replace the motor.
Yeah.
It's shorted internally.
The controls are telling it to run when it shouldn't be, so it's in the control of the motor. So. And you guys need to invest in some of those ECM tools. They, I don't know, they're $40, $50.
Yeah.
But man, it's going to make troubleshooting your life much easier. And most guys can write off tools, even if it's only a portion of it at the end of the year.
Yeah.
Someone's asking, what is the purpose of the common wire?
Well, you've got to complete a circuit. And if you want to call the one side the hot wire and the other side the common wire, it's just the other side.
Completes a circuit. You have to have the plus. You have to have the plus 24 coming into the coil. If this doesn't go back to 24 common, if this doesn't go back, you don't complete the circuit. Now if you apply 24, the coil will energize. Now that coil is not energized. So this could be a pressure switch or anything like that.
And Brian's finger's all black.
I know. Sorry, I messed up the board. It's all good. Producer, Red.
Ah, nice.
All right. I told you it was hot in here. There we go. Thank you.
Jersey Hvac by Carl is asking, parallel versus series phase monitors? Train Factory uses series monitors. I installed 4 monitors to a building that lost a phase and all 3 units blew. The 3-phase motors as per county requirements.
Typically, phase
I think
monitors.
there's more to his question.
Yeah.
But
Typically, a phase monitor is looking to make sure that you have all 3 phases and they are in the correct rotation. A voltage monitor would be used more on a single phase piece of equipment because you're not going to change rotation by swapping 2 wires. So I think you're talking about 2 different devices.
Cool. Keep dropping your questions in the chat. We haven't stumped them yet, You still need to stump them, so
But the
everyone
idea,
try your
they're
hardest.
going back to the phase monitors. Phase monitors, I mean, you can, there's a tester to make sure that you're phased correctly when you hook up the machine. The other one is phase monitor protection that is supposed to drop out the low voltage circuit.
Well,
So you don't energize if you do single phase the machine.
Right, but think about one of the biggest reasons why you have a phase monitor is on some of your larger compressors, if you run them backwards for just a few seconds, you're screwed.
So
It's
it does,
done.
it does both, right?
Yeah, so it's gonna protect you from running backwards.
The new scrolls.
Yep. It's also gonna turn around and if you single phase the motor, you're going to have more time, but you're still gonna damage the motor, trip overloads and things like that.
Yep. We had that kind of time.
Let's do one from Josh. He says, when wiring a compressor, why is both wires black instead of one black and one white? And why doesn't it matter which I send to L1 and neutral?
You want that or you want me to take that one?
So Josh, thanks for the question. But what compressor do you have that only has two wires?
Well, 230 single phase
On a compressor?
from the L1 and L2. Not capacitors or any of that kind of stuff. But the thing is,
Common start run or L1, L2, L3?
right, but you have 230 single phase going to the compressor
And,
with the capacitors and everything else. The
and
thing
the
that's
the shorter answer, I believe, is electricity doesn't give one iota crap what color the wire is.
yeah. You know, I mean, really, the only colors that are typically set in stone is green is ground and white is neutral.
Okay, Josh has compressor, but now he's saying, "Oh shit, my bad." I meant to say condenser. So now let's go back and look at that again. When wiring a condenser, why is both black wires instead of one black and one white? Because it's typically, now totally changes the answer. You have two hots and a ground instead of one hot, one neutral, and one ground. That's why you've got two blacks. Yeah, electrical code requires that any hot wire has to be a color, not white. White is reserved for neutral, and green is reserved for ground.
On a good day.
On a great day.
Yeah. I've seen black, white, and green for three phase.
I get it, man. I get it. Thanks, Josh. Thanks for clarifying your question too.
When replacing a bad compressor, what else should you replace and what else should you check?
Why the compressor failed?
Yeah. I mean, if you're talking the refrigerant circuit, you're going to want to do definitely dryers. If you're talking electrical on three phase, I'm going to check the contactor. I'm going to check my voltage, make sure I don't have an imbalance. If I'm changing a single phase, I'm probably going to change the capacitors. Depends more or less what.
Well, what did the compressor fail on? Was it a locked rotor? Was it a grounded, shorted, open winding? That's all part of your troubleshooting.
Yep.
If it's locked up, what caused it to lock up? Did it get a flood back and lost all of its oil?
Well, and anytime you replace a single phase compressor, you want to replace your capacitors.
You want to replace your capacitors, any start components, but it's just part of the troubleshooting process. Once you replace that compressor, now you have to look at what it failed on, and that is what you want to look at when you start the machine back up. Obviously, if something broke internally and it's locked up, then I would be looking at the refrigerant circuit for restrictions. You're going to change the dryer, you're going to do all that stuff anyway. Chances are you fixed the problem before you got there. Even if it was overcharged, you've removed all the refrigerant to change the compressor,
Starting over.
you're not going to overcharge it. But that's what you need to look at. If it was grounded, shorted, then look at your incoming power, look at your contactors, see if you need to replace those because they're burnt up, contact points, things like that. So, sorry, got into the weeds leads on Alan.
Your turn out there.
Why do you read continuity on hot side of a 24-volt transformer?
Well, when you
With no power to it, is to see if the winding is opened up or not. It determines whether you've got an overload on the 24-volt side or if you took a power hit on the high voltage side.
yeah, and then you can read the 24-volt side to the common. Huh?
There's our common questions.
There we go.
All right, we're gonna do another one that was from tech support. So this one was sent into Dennis. Outside air temp is 80 at a train package rooftop. Call for cool, but compressor and condenser fan motor are not running, and all their safeties check out.
Is there power on?
So the first thing that would come to my mind, obviously you got to check for your power, presuming that you have power, presuming that you have control voltage, presuming all of your safeties are closed. But a nice 80-degree day, did you lose the controller on your economizer?
Yep.
So the economizer is holding the compressor out in its circuitry, and if you lose the controller, chances are the outside air dampers didn't open because it just doesn't know what to do. But it's
So now it's not a
Holding the
safety, it's an interlock.
now it's broke.
Okay, what is the purpose of a motor grounding ring?
Oh,
That's a good one.
yeah. What happens is we used to call them bearing currents,
Yeah.
and it was due to the high frequency of the drive would cause pitting of the bearings.
Yeah.
So they put a ring on there that would allow carrying those bearing currents to ground and avoid damaging the bearings.
So look at it, if that went over your head, look at, and I've seen quite a few.
Uh-huh.
When you put a VFD on a motor, and you see it a lot where people have converted and they've taken the contactors out and put VFDs in so that they have soft starters. And think of it as static electricity. Drag your feet across the carpet and go touch somebody's ear, and that's what's happening in the motor. Is it's getting that static electricity and going through and hitting the bearings. So by putting the grounding ring in, you take any of that static built up and send it right to ground.
Yep.
All right, explain pulse width modulation.
Oh boy.
It's a Mike kind of question.
Oh,
Oh, here we
Mikey's
go.
on it.
world.
Do you need me to move?
You can move.
Load shift.
We can erase the blue one too. If
I
you
can erase that part.
need more
Brian,
room.
let me borrow your hand.
There's your tissue.
All right. So I would hit you with the question, is the voltage going out to the motor on a variable speed drive, is it AC or DC? And, you know, it's not really fair, but anyway. So what happens is, if I have plus 700 volts, and I have 0, and I have minus 700 volts, what ends up happening is the width of the pulse, if it's very, very quick, and then the next one gets larger, it stays on longer, and then it continues to build, and then it kind of works its way back down. And what happens is, if you look at the average of these different points, what you have is what now starts to look like an AC sine wave going out to the motor.
Cool.
You like that one?
I did. That was I knew you would perfectly explain that.
That was my world.
Okay. Getting back into my safety zone.
There we go.
Hey, somebody stole my buckle. There it
Sounds
is.
like a personal
I
problem.
know, it happens.
All right, one from Jason. With an air conditioner consuming 8,500 volt amps with a 240 volt supply, what would the minimum total circuit amp be?
When I got into the trade, they told me there would be no damn math. I know they lied, but I don't have a calculator with me, Jason, and I don't do it in my head.
Yeah, it's just your VA is volts times amps. And, you know, the voltage, did he give the incoming voltage?
240.
So divide 8500 by 240. Times 1.25 for safety factor.
Here we go.
We come up to about 44.27 amps.
Thanks to the producer, they have quick calculators back there.
I'm surprised Danica didn't do it in her head.
All right, please explain the flux capacitor.
It is to get that little silver car that used to be filled with Coke through the movie. There you go.
Now you're gonna have to explain.
Yeah, I'm gonna draw that one out on the board.
That would be John DeLorean, who tried to fund his car company through illicit measures.
Why would a single-phase compressor run backwards? Why would a single-phase compressor run backwards?
You can get a single-phase fan running backwards if you got bad capacitors, and say it was back spinning when it started. Would be the only possibility I can think of.
Well, when I think of a running backwards would be well, I guess you could see it in a scroll too. It would be really loud, really noisy.
Yeah.
Result, if it was a piston, it's not running backwards. It's just.
Yeah, because it's going the same way. Yeah, that's
But
the
yeah,
only way I can think
it would
of.
be a bad capacitor.
Yeah.
So we probably have more guys listening now and watching us. So here's our reminder: the next Buckle Up with Mike and Brian is March the 18th at 4 o'clock. We're going to be covering charging and tuning. Also, guys, coming in the not too distant future, we're going to be able to look up parts. Don't forget, you're going to be able to look up parts in our app.
I think the one that really excites me is the forum, because I've seen too many of the chat rooms where people like to pick on people, and to be blunt, we're not going to put up with that crap. It's all about positive and helping other people, and what we're really hoping is that we get the one guy that's worked on one problem that nobody else has seen. Somebody asks a question, he jumps on, here's the answer. And we got to help each other, guys. The industry is hurting.
I'm looking forward to it as well, because it's going to be a little bit more live with guys being able to look at their phones all the time. If you're stuck on a job, you can jump on the Blue On forum and look at post questions, and then everybody in our beautiful community and our new format coming through for looking at lines and models. We're going to make the equipment search a little bit easier, a little bit more user-friendly, if you will. I know I've told as many people as I can, and tell your friends, when you're looking up equipment, you go to the manufacturer and then type in 2 digits at a time. Don't try and put in the whole entire model number. And then our new format that's going to be rolling out, when you see the parts, you're also going to be looking at the manufacturers, the series, whether it's a Predator or Liebert Minimate or that kind of thing, and then you can look up the model numbers, and then you'll be able to look up parts. Man, it's growing.
Good stuff.
We're here feeding what you guys want. I know I've talked to several of you out there that we're technicians building an app for technicians. I know it sounds corny as hell, but download it, get it rolling. My producer is telling me something.
Tomorrow you probably want to update your app because there's some really cool new stuff coming. So, and that's not a bad idea to do often, because we've got some amazing people that put in new functionality. So go ahead and just update your app from time to time, and you may be pleasantly surprised.
Yeah, it's gonna be badass. I don't know how else to
It's already
say
badass.
Badasser?
Is it
I
gonna
don't
be
think
badderasser?
I don't think badderasser is a word, but
I don't know,
we'll
but
go with
we made up for it before.
So the forum's going to be great. I can't wait to see the interaction between not only the Blue On techs, within my internal community, but all of you guys. And I was out and got to see some of you last week, and it was fantastic. Had a great time doing that. And I love talking to you guys on the phone. If I can, this morning, I'm driving in and it's like, hey, tech support call comes in and it's like, sorry dude, I can't look it up on a computer, I'm driving between jobs. And he's going, holy shit, you guys are actually working? And it's like, yeah man, I didn't I'm not sitting up in a comfy chair, we're actually doing this stuff. So tell your friends, keep it rocking and rolling, guys. I'm sorry, I was rambling on. Do we have any more questions coming in?
I think we're gonna wrap it up right now. We have one more actually. What is the purpose of a soft starter for a condenser?
Inrush current. If that makes sense to you, great. So let me back up. Across the line draws higher amps. So a soft start means that you give, it's basically a VFD that just takes it from 0 to 60 hertz.
Another part of that is if you've got condenser fans that spin backwards and you slam them across the line, they're spinning 4,000 RPMs backwards, and now you're going to run them 4,000 amps forward. You have a tendency of breaking stuff.
Yeah,
So
seen that too. But soft starters are just to prevent the inrush current. So
that's what they tell you.
that's what they tell us.
So again, be sure to tune in March 18th at 4 p.m. for charging and tuning. Come with your questions. Nobody stumped them this time, guys, so let's try a little bit better next time.
We
Harder
get the answer
questions.
to, does AC go from plus to minus or minus to plus?
No, but why do some commons get grounded in 24 volt circuits? It's because that's what the manufacturer wanted to do.
And you'll never get a good explanation from them.
Peace, guys. Stay
Thank you.
safe. Call us. Download the app. Tell your friends. All new stuff. All wonderful stuff coming. And I can't wait for you guys to see our new studio. This is, insane. Love you guys. Thank you very much. Peace.
Have a good one.